Alrighty, so we're going to talk about populations and samples. We're getting ready to launch into the last topic of our unit, which is really good, but we want to talk about populations and samples. It starts off very simple, but it gets quite challenging pretty early on, or pretty quickly. So I'll pay attention, make sure we get the basics sorted, and then we can go from there. So to start with populations. Now populations include an entire representation of a group. So if I was talking about the population of this school, that would be every single member in every single grade, including the staff. Cool? That would be the population of our school. It doesn't need to be every single person in the world, it just needs to be of a group or a category that we are focusing on. When we want to collect data, we can collect data in a couple of ways, but if we are collecting data from the entire population, it is called a census. Now you'd be aware of that. In Australia we do a census every 4 years. They send out stuff and you've got to try and respond and send it back. That allows them to collect data about demography, how much money people are earning, etc., what they're doing for work, where they're living, all that sort of stuff. So we do one of those every 4 years. The reason we do it every 4 years rather than every year or every 6 months, they'd love to do it every 6 months. But why do they do it every 4 years? It's expensive and it's a pain. It's very hard to track down everyone to do the census and that sort of stuff. So it's not a very efficient way of collecting data, but it's the most accurate way of collecting data. Cool? But what we can do is sort of find a middle ground. We want to try and get accurate data, but we don't have to do all the work. So to do that, we can use samples, surveys of the samples of our population. Now samples are just collecting a subset of our population. We're just looking for a subset. Now the problem with collecting or identifying samples is what? What's the problem with?
Doesn't include everyone.
Doesn't include everyone. And what do you have to be mindful of? Bias. So the idea that we're trying to get is a perfectly random sample that allows for the entire population to be represented. The problem with random samples are not that random. How do you collect data in a purely random way? Let a computer do it. That's a good way to do it.
It's not random.
But so let's say I wanted to identify the entire population. I wanted to talk to the people who shop at Canelands, for example. I wanted to get some data about the population who shop at Canelands here in Cairns. Okay. And it'll do what? Ask people. So when I walk up to someone and they refuse to engage, will that happen, do you think?
Yes.
And do you think the people that refuse to engage all have similar characteristics?
Yeah.
So am I getting a biased sample or a truthful sample of the population? Getting a biased sample. So it's very, very difficult to actually truly get a random sample, but there are ways. So there are three effective ways, or three ways in which we can identify a sample, and we have to be super aware of bias. We spend a lot of time talking about bias, but bias is what prevents sampling from being appropriate or accurate or allowing us to do anything with it. So a random sample is just exactly that. Participants are selected at random. The larger the sample, the more representative it is. So for example, I'm going to do a random sample. I'm going to walk up to the first kid I see in the school and ask them if we should abolish sports uniforms.
Abolish what?
Sports uniforms. Now if I ask one kid, what's the problem with that?
Only one is.
Like Jean, let's say I walk up to Jean, and he's got to wear his formal uniform every day, and he resents the fact that there are members of our community that don't represent the school as proudly as he does. So I walk up to Jean at lunch and say, hey Jean, I've randomly selected you to complete the survey, should we abolish sports uniforms and pads? And he says, yeah.
Wow.
Random sample complete, I'm going to go with my data. Would you be happy with that result? Why not?
It's Gianna answer.
Yeah, but I could spot off 50 other kids that probably say the same thing, correct?
Yeah, only this one.
Only kids that wear formal. But there would be a proportion of, now the majority of our school would vote very vigorously in formal no, correct? But there's probably a 20% chance the first kid I walk up to says that. So there's a 20% chance the data I'm getting doesn't represent So how do I avoid that?
Ask everyone.
I don't want to ask everyone, but I ask more people. The more people I ask, the less likely my data is to be not representative of the population. So stratified samples, and this is really good. We talk about a school context. This is where we categorise people into groups, and then we select a certain number from each group that's representative of their size in the population. So let's say in our school there is approximately 200 kids. There's 200 kids in every grade, except in grade 7 there's 300 and in grade 12 there's 100. So if I was doing a sample of, actually, yeah, we can do that. No, let's go 100 if I don't have to do the math. We can do 100 per grade, there's 50 in grade 12 and there's 150 in grade 7. It's not that much easier. Anyway, if I got 2 kids from year 8, 2 kids from year 9, 2 kids from year 10, 2 kids from year 11, how many should I get from year 12?
2.
1. How many should I get from year 7? 3. Does that make sense? So you break up the sample representative of their population size within the whole cohort.
Why is that equal?
Well, because you don't make up an equal representation of the school.
Ratios and stuff.
Correct. Ratios and stuff. So, selected based on representation of subgroups. Are we happy with that? Well, these are just very brief introductions, and to be fair, random is probably the most important. The next one is probably the most fraught with danger, systematic. So systematic is whereby I will operate my sampling technique through a system. I want to identify screen times of students within St Patrick's College, so I'm going to ask every 10th kid that walks through the front gate between 8 a.m. and 8:30 a.m. It's relatively random, but I've got a system. I'm going every 10th. What's the problem with that?
A little bit biased.
Can be very biased. How so? Who do I not include when I get every kid that goes?
Stragglers who come in late.
People who rock up late. Who else?
Teachers.
People who come early, people who come late, people who come, like a lot of the bus kids, for example, would have very high screen times. Why? Sit in the bus, particularly the ones that are going from like Serena and Eton and that sort of way. So if you're sitting on a bus for 2 hours and your bus rocks up late every day, I'm not going to get you, correct? So I've automatically removed a group from my sample that is not representative of the whole population. So a system is applied to collect data, to collect the sample. And you can write an example under each of those. Now that I've given you a bit of time to think, I want you to give me an example of how you would do one of those samples. It can't be the same as mine. So I don't want to see the 10th kid in the school. I don't want to see 2 kids from each age group except 1 from year 12 and 3 from year 7. I want to see your own representation of that. Happy with that? So I can think of plenty of sporting contexts for a stratified sample, random as heaps, and then for a systematic approach, I'm sure you can develop a system. But cool. That's an introduction to sampling with a slight taste of bias.